Hi guys, we have been successfully to be able to we have been successfully been able to implement our smart contract according to our problem statement here. So now the next line of action is to deploy the contract to the blockchain that they may give to us, but I realize some issue. So basically, retrieve student in this our retrieve student information function here, we are not like if you are doing if you are checking if the age is equal to zero, then definitely it is not the logic is kind of wrong. So what we need to check here now is to check if the student record is not equal to zero. That is if stu- I- no, sorry that is what we need to check here now is to check if the student age is not equal to zero. So if the student age is not equal to zero, then definitely a record as it already exists, then we can go ahead and retrieve it. But if the student record is equal to zero, then no record has been stored in the mapping. So that's why we need to change it from equal to is not equal to zero. Then we come down here to also change this from equal to zero to not equal to zero. So finally, everything will work as expected. Now it is now time for us to deploy our code to the blockchain. So now I want to like I want to draw our attention to some important stuff. So now in our fundamental class, when we talk about when we talk about the fundamental aspect of the blockchain, when we are looking at things like private key, public key, and others, then there was a section in which we talked about testnet. So now in which we refer testnet to as fake blockchain, in which enables us to simulate which give us we describe testnet as a fake blockchain that enables us to simulate how the real blockchain will work, because the reason why we have a fake blockchain, and this fake blockchain they are basically refers to as testnet. So the reason why we basically have fake blockchain is because whatever activities we are performing on the blockchain, all those activities, and if the activities is causing state changes, so these various activities they require gas, and it won't be nice if what all we just want to do is to check if our code is working as expected, we begin to pay fees. So that is why this fake blockchain were created to enables us have the kind of to enable us simulate how the real blockchain will work, and to give us that guarantee that when our code gets to the real blockchain, that is going to work as expected. There won't be any issue. There will not be. We won't have any issue when our code have gotten to the real blockchain. So that's why the fake blockchain was created. So now Remix comes with a kind of like fake blockchain, that is Remix itself. It comes with a kind of like fake blockchain that enables us to it comes with a fake blockchain that we deploy our smart contract to, and enables us to have this kind of it enables us to simulate how the real blockchain will be. So now if you see by my left, so now so now so now at this stage we want to deploy our code to the smart contract. So now we now need to do some settings before we deploy our code. Now I want to walk you guys through this UI. So now if you see at by my left, then we have various options. We have the remix VM, the remix VM Berlin, injected provider. All these are all these are fake blockchain in which we can there are various fake blockchain in which we can deploy our contract to. So like the remix VM and the remix VM Berlin, they are basically fake blockchain that remix itself provide for us. But when we start choosing the remix VM and the remix VM London and the remix VM Berlin, they are basically fake blockchain in which remix itself give to us so that we can simulate the way the real blockchain will work. But choosing the injected Web3 option, so injected Web3 option is when we are start deploying to various testnet that we have. We have various testnet. We have the Goerli, the Kovan, and all that. So this is just what this section is for. It enables us to choose the blockchain we want to deploy our smart contract to. So now, if we look at, so now remix also, it give us like a fake account. So if you are deploying your code, if you are deploying your code to the blockchain, it costs gas fee, and you need to have at least a certain amount of ether in your account. So same thing to remix give us a fake account, and the account has a certain amount of ether to it, so that when we are deploying our code to the fake blockchain, a fake ether too needs to be paid so that we'll be able to deploy our code to the blockchain. So the major reason to create a fake blockchain is to simulate how the real blockchain will be. So now that's why we need a specific amount of ether in our account, so that we'll be able to deploy our code to the fake blockchain, and we'll be paying a fake ether. So now let's look at this gas limit. This gas limit basically enables us to set the maximum amount of gas we are willing to pay to perform a specific transaction. So this is what this gas mean. So that is, if you are performing, we said transaction are action that causes state changes to that are action that causes state change to the blockchain. And once there is state change, so immediately we've created this transaction, we need to submit a transaction to the blockchain. After a transaction has been submitted to the blockchain, some set of people need to validate this transaction. And when I mean validate basically means that the action you are performing is actually correct. So let's imagine a case whereby someone created a transaction, and the person submit the transaction to the blockchain. So, and in the transaction that the person submitted, the person currently have 10 ether in his wallet, and is trying to send 100 ether to someone. So now this is where the works of the miner come into place. So the miner, they validate transaction, and once they realize that okay, the transaction they are trying to perform is correct, then they would now do the various state updates that needs to perform. And for this miner to be able to perform this state update, the this state update requires a series of computation, and this series of computation is energy intensive. Like look when you go to a barber shop and you want to barb your hair. Of course, a barber won't barb you for free. He's going to charge you a certain fee to help you barb your hair. And part of the reason why he's going to charge you is because he's paying money for energy, and the source of the energy is petrol. So he's paying money for this energy. So that is the reason why he has to charge you, so that he will be able to recover those fee in which he will be able to recover those fee in which in using setting up his shop, so that he will be able to offer you his service. So same thing too comes to the works of the miner. They update the blockchain, and for them to update the blockchain, they need energy, and the energy in which they use in updating this blockchain, it costs money. So that is why we need to pay them a certain fee, so as to encourage them to keep on doing the good work. So as to pay them, so that they will keep on doing good work they are doing. So and the money we pay to them is what we basically refers to as gas. So now this gas, so now if you are performing a transaction, you can actually set the maximum amount of gas you are willing to spend to perform a particular transaction. So and that is what this gas limit is for. So now imagine, and so now this value session, imagine a case where you are interacting with a smart contract and you need to send a specific amount of ether at you need to send a specific amount of ether to that contract. So it is with the help of this value session we are able to send ether to the contract. So now that is what this section is for. Just all you just need to do, enter the amount of ether you want to send to the contract. So now we've looked at this remix UI that enables us to handle deploying and running transactions. Now let's now deploy. First we are going to deploy our smart contract to the to some testnet like Goerli, and for now we just deploy our smart contract to Goerli. We won't be using just Goerli for now. Then we also deploy our smart contract to the local blockchain that Remix give to us. So now to select the blockchain we want to deploy our smart contract to, we click on this Remix VM London. So this Remix VM London is basically the local blockchain that Remix give to us. Then you click on the deploy button, click on this orange button here to deploy your smart contract. So now we've been able to what successfully deploy our smart contract. So this is our transaction. This is our transaction receipt. So this is our transaction receipt that contains the various the gas. So now the gas and the cost um so now, whenever we are performing action that causes state change of the blockchain and in which we describe such an action as transaction. So now such an action like deploying a smart contract to the blockchain. So we are actually creating a transaction. A receipt is always returned, and that receipt just contain information about the transaction that we perform. So for example now in our own case the transaction we performed was deploying a smart contract to the blockchain. So now this is the receipt that was returned, and you can basically see the transaction receipt as an object that contain various information. This is the transaction hash, the from, that is the address that is creating the transaction. We have the amount of gas used, the transaction cost, the execution cost, the input, the decoded input, the decoded output. Then we have this log. So this log also this log okay, as we move on into the course, we will understand how to effectively use these various items that are in this transaction receipt, because this transaction receipt actually it enables us, it helps us when we are integrating our smart contract to the front end. So that is one importance of this transaction receipt. Just know that whenever you are creating a transaction receipt is returned that contain various information such as the address of the person causing the transaction, the amount of gas that was used, the logs and all that. So then this value is the value if ether was sent when the transaction was performed. So those are the items that are present in the transaction receipt. Now we've been able to successfully deploy our contract to the blockchain that Remix give to us. Now, if you check this section here, this section now is this section now it gives us an interface so we can interact with our smart contract. Now you will see various now at this section here, this is the address of where our contract is living on the blockchain. Then we now have various the balance now is talking about the current balance of the smart contract. So and currently our smart contract is having a zero ether. Now we have the delete student button, the retrieve student button, and the store student button. Now the reason why we are having this button here is because the visibility of this function is public. That is, we set the visibility as public, so then whatever remix itself automatically give us a UI so that we will be able to what interact with the various function that Remix itself give us a UI so that we'll be able to interact with all these function because of why is Remix giving us this UI? Because we set the visibility of this function as what as public. So that is why we have this various button here. So now let's now interact with our contract and let's see how it works. So now so the what you basically implement is the delete student functionality, the retrieve student functionality, the store student functionality. So now the way we created this delete student functionality is that okay, if we want to delete a student record that does not exist, then we want we want the Solidity compiler to throw an error that this student record does not exist. So just add record before you can make attempt to delete record. And also we also make sure that it is only the administrator that is calling this function. So now let's test out if all these functions are working as expected. So now paste your address. So now I've copied my MetaMask wallet address. Let me copy my MetaMask wallet address so I can try make attempt to. I've now added a record for my address now. I've not input any record for my address. So let me copy my wallet address. Let me paste it. So let me copy my wallet address. You know what? Okay. Then paste it. Let me open terminal so you can see. Now I've not input any record for my address, and I said any attempt to delete any record that we need to. So if we want to delete a record, we need to check number one if it is the administrator that is calling this function, and also if the record we want to delete, if that record surely exists. So if it is not the administrator, we want the function to throw an error, and if the record does we want to delete does not exist, we also want the function to throw an error. So now for my own case now, no record has been added for my own in my own case. Now let me click on the transact. Then you can see now you can see Solidity the compiler Solidity actually throw an error that through an error. And what's the cause is saying that student record has not been added. So nice one. My function my delete function is working as expected. Now let me change the account. So now let me change my account. Let me change it to this. Let me change it to this, and let me click on delete again. As I said now, I said so as the administrator is set at the point the administrator is set when we are deploying our code to the blockchain. And with the help of this special function that comes with Solidity, which is the constructor function. Immediately our code is deployed to the blockchain, this constructor function is called, and this msg.sender, it is the address of the person deploying the it is the address of this person deploying our code to the blockchain. So then we then initialize this our administrator variable here with the msg.sender. So it is at the point of deploying our code to the blockchain, that is when we are setting the administrator. So now in my own case now, the account we are on when we're deploying this code to the blockchain is this 0x5b3. So this is the account that deploy our code to the blockchain. So now let's now change the account from this to a new account now, and let's now click on delete to see if Solidity to see if Solidity will throw an error, because currently now it is no longer the administrator that is calling the delete function. Now let's check. Can you see Solidity definitely threw an error? So it means our delete function is actually working as expected, and our error message here is only administrator is allowed to call this function. So now so you can try out the remaining function in your own free time. So to just you can try out the remaining function in your own free time. So now we've been able to successfully deploy our code to the fake blockchain, or we say the local blockchain that Remix give to us. So now let's now deploy our smart contract to a testnet. So testnet like Goerli. So that is where we will be deploying our smart contract to. So then, and I said this tab here, it enables us to set the environment. It enables us to select the blockchain we want to deploy our smart contract to. So now all you just have to do, come down here, click on injected web3. So after clicking on injected web3, our MetaMask will pop up. So our MetaMask will pop up, then for so that we can connect our MetaMask to the Remix. So now we've been able to connect to the Goerli blockchain. So the current blockchain now, the way this works is the current blockchain that our MetaMask is connecting to will be the current blockchain that our Remix 2 will be connected to. So that is, if I change the network I'm currently connected to if I change, so we can also refer blockchain to as network. Don't be confused when I say network or when I say blockchain, they still refers to the same thing. So now when I switch my when I switch from the Goerli test network to the Ethereum mainnet, you will realize that the blockchain I'm connected to here changed to what? The name changed to main one network. So if I change back to Goerli testnet, so it changed back to Goerli 5 network. So now that is the way it basically work. So now it work with this injected web3, enable us to connect enables us to connect to whatever it enables us to connect to whatever blockchain we are currently connected to on MetaMask. So now, so with the help of the MetaMask, we've been able to connect to the Goerli testnet. Now let's now deploy our code to the Goerli testnet. So let me click on deploy. So now we are creating a transaction. So because we are deploying this code to the Goerli testnet, don't forget we are creating a transaction, and if you are creating a transaction, you need to sign this transaction. you need to sign this transaction, and to sign this transaction all you just need to do is click on confirm. So now we've been able to successfully deploy our smart contract to the Goerli testnet. So now let's now no we've been able to deploy our smart contract to the Goerli testnet. So now let's now check it out on Etherscan. So as you said, we talked about block explorer. So various blockchain have different explorer. Explorer just enables us to look at various activities that is taking place in the blockchain. Now, for blockchain like Ethereum now, the explorer in which we use in checking out the various transactions that are created on this blockchain is Etherscan. So now with the help of Etherscan, we can check out various transactions that is taking place. Is the transaction successful, the amount of gas that was used. So now if you look at now, we've been able to successfully deploy our code to our Gweli testnet, and these are the various these are the transaction receipt that was returned. We have our transaction hash, the status, the block number, the timestamp, the firm, that is the address that deployed the contract, the value, the amount of ether we send, the gas price and all that. So we've been able to successfully deploy our code to the Gweli testnet, and we've been able to successfully deploy our code to we've been able to also deploy our code to the Remix local blockchain. So I think this is where we are going to wrap it up for today, and also it may give us an interface in which in which we'll be able to interact with our smart contract. So this is where we stop for today. Have a lovely day.